You hear that? Yeah, that's gunshots. And people always ask me, why do you carry out in the desert? Because it sounds like that. See this? It's called the trumpet plant. And they say, oh, if you find a trumpet plant, there's gold there for sure. No, it just means there's a lot of mineralization there, son. Horsetail is the same thing. If you find horsetail, there's a good chance there might be gold there. These are trumpet plants. You can't miss them. What's this black rock right here? It's called basalt. And it's running up and down, so that means it's what? A dike. So it's a basalt dike. And what's it cutting in? This is porphyry andesite. A fissure opened up in the andesite, and then this stuff rushed up through, the basalt did. Because it came out, it cooled fast, and the crystalline ground mass in here is really, really small. It's real fine. Why am I showing you this? Well, I want you to understand it. This is considered a mafic rock. Mafic meaning what? Magnesium and iron. Now, if it was granite, this would actually be rhyolite. If it was a dike, that would be felsic. Felsic just means feldspar and silica. You got two ends of the spectrum. Then you got intermediate in the middle. That's usually what andesite is. Well, why am I showing you this? Well, if you have any of these diabase dikes or basalt dikes that run through creek beds, they're great for trapping gold. Now, if you're looking for hard rock gold, what are these good for? If you're in a region where there's a lot of granite and you have diabase dikes or basalt dikes running through the granite at the contact zone where these two guys meet, and a lot of the gold deposits can form at that contact zone. Remember, I told you contact zones are important, whether it's placer or if it's hard rock. There's a lot behind that. Diabase and basalt dikes, feeder dikes that come off volcanic, is that a lot of times where these dikes come in contact with other material like beautiful looking granite, see that? Where this comes in contact with this, it creates contact metamorphism because it's so hot. And I want you to see something, look at this. Look at that, see that coming off of it? And you can see it right here, right there. Where the granite was getting really hot, you start getting this material right here. And this can have gold in it, see that? There's another one right there. There's another one right there, all along the contact zone. And look at this. See that? Isn't that beautiful looking material? Yeah, that's what I'm talking about. See all that box works in there? They call that box works. And it's all along this contact zone. See that? Isn't that beautiful? And then all this nice, chunky red material. I'm taking that back to see if there's any gold in it. See the sulfides in there? Right there. Look across the way there, you see that? Those are volcanic plugs, or necks, same thing. The rest of the center cone's obviously weathered away. You see that black one over there, basalt? See that feeder dike coming right off the side? What's this big old ugly looking thing in the middle? It's a basaltic dike. Now on top of this ridge is a lava cap, and there's a fracture running through this alluvium, and this little guy right here forced its way through. But it's a big old fat basaltic dike. You can see where the freezing took place here first. And why do you suppose they're digging here? Well, it's simple. There's a contact zone right here. See that? So you have this hydrothermally altered hanging wall, and then you got this andesite porphyry right here. You see that? So this is the andesite porphyry here. And you see this? This has been hydrothermally altered. Looks like propylite. You can see it right there too. It's really good. See how it's been altered red? Well, a lot of times in these contact zones here, you can have what? Mineralization formed there that would have gold in it. When you're around these old mines, I don't advocate going in them, but I do advocate you go looking around the old mine dumps, because sometimes the old timers threw out low grade because they didn't want the low grade, they just wanted the high grade, or they couldn't see it. Small shaft here, and I've got tons and tons of quartz here, and you can see a beautiful looking vein of it. That's a little stringer. Remember, you got stringers, you've got swarms, you've got veinlets. Remember that. You're gonna see that in your USGS reports. See that vein? You got the porphyry andesite on the left, andesite on the right, and in the middle, look at that. What is that? It's a brecciated quartz vein. And they were following that down. You can see it all the way down. There's a couple parallel veins next to it too. Probably different timelines on deposition. It comes up here, right there. As you can see where they've been digging right there. And I'll probably sample that too. See if there's anything worthwhile in there. But that's what I want you to do when you come out to these old mining districts. Make sure it was free mill, native gold that they were pulling out. Looks like a wellhead, huh? Now this one's not even on any map. I just happened to be wandering out in the middle of nowhere and I stumbled upon some old diggings. Don't look like it was very profitable because the old timer stopped. But I'm gonna look at it, you know why? Because it might be profitable for me. And that's what you should do too. I got this huge dike running along the hill. And you see where it was exposed? Oh yeah, you see all that manganese oxide on the outside? Can't even really tell what it is. Then you get down in here where it hasn't been weathered so much. Ooh, and you can see the mineralization in there. See all that mineralization? And if you get a good look at this, you'll see what? Sulfides in the mix. That's why it's always important to look for these outcroppings. You'll have quartz outcroppings and rhyolitic outcroppings. So you gotta look at them, especially where old timers have been digging. Now I already saw sulfides in the mix. I already broke a chunk off and used my jeweler's loop. And there's sulfides all through there. And I could tell too, just by looking at some of this rock that it's sulfide. There's a good example right there, see that? So the red hematite, iron oxide, then you got the yellows where the sulfur's oxidizing out. That's a dead giveaway right there, that's sulfides. You break it open, it'll smell like sulfur. And that's like I told you, sometimes gold rides in sulfides, right? And this is what you should do too, is look for these little prospect pits that aren't in any maps. You go out and you prospect and you look around, you put them on your maps. You get samples. It's important, why? Because if you happen to stumble upon bonanza type vein structure and epithermal, woo-wee, you can retire. That's right, Sonny Jim. Remember, low sulfidation, not high sulfidation. I'm gonna check his high grade, low grade piles. They're all over the place here. And I'm gonna pull samples from that. And then I'm gonna sample across the vein like I told you. Remember I told you that? He said, you know what I'm gonna say, huh? Ooh, you better, so come on. Let's go. Take a look at this. I don't advocate getting close to these collars. This is a collar, that's a shaft, vertical shaft. You can see the hanging bolts down there. You see the hanging bolts, how they built this? And in one of my videos, I'm gonna show you how to do this, okay? In case you wanna drop your own shaft. Why am I showing you this? Well, I've got a whole bunch of shafts in the area. I got 4, maybe 5 shafts and a whole bunch of little pits. And you're thinking, Jeff, why the heck did they dig so many shafts? Was there one vein running this way? No, silly boy. There's a whole bunch of parallel veins running north to south. And they knew that. So all they did was they were scratching the dirt, trying to find one, scratching the dirt, trying to find one. And then what they do, they'd sink the shaft down here, and then they'd start drifting along those veins to try to see if they got rich. Obviously they didn't. This is a drift mine. What they've done is they've dug down through the different layers of stratum, and they're trying to find that thin layer of gold. It's just in this soft conglomerate gravel, this alluvium fan that we're standing on. So I got one over here and I got one over there. That tells me there's placer gold down there. They usually don't have any type of framework. You can't really spot them. And sometimes the mine dumps around them are real tiny. They don't look like nothing because they've eroded away. Ah, nothing. I feel like you caught Cornelius. See all these little veinlets in here? And stringers? You get a lot of them. It's called stockworks. It's when they just scatter throughout the whole rock. Now this is a fissure-filled vein system. This used to be a whole bunch of fractures in this host rock, and then it got filled up with all this quartz when it was in liquid form. Tell you what, that's another thing I gotta bring up. Portals, the first 20 feet, most dangerous, because that's where these critters hang out. Beautiful looking rhyolite right there, you see that? You can have sulfides and gold in this stuff. It's from granite. Granite's intrusive, cools inside the earth. This stuff comes up fast, so it's fine grain. It's felsic, which means it's got what? A lot of feldspar, a lot of silica in it. And intermediates, like your andesite, and your mafics, like your basalt. Mafic meaning magnesium and iron. And then of course you got ultramafics at the very other end of the scale. Andesite, its parent rock is diorite. And sometimes you have the two mixed together, granite and diorite. They call it granite diorite. Getting back to andesite, it's volcanic extrusive. Now it can come in all host of different colors. This one's green. I found a lot of gold in andesite that's got green in it. Then what's that behind me? That's a whole bunch of rhyolite poking up out of there. And yeah, it comes in different colors too. Ooh, you know what that is? That's right, that's black sand in the wash. And just oodles and oodles of it. That's silver. Ooh. And there's tons of sulfides in here. You can smell it. Ugh. And yeah, there's gold out here too. And you can see where they had froth flotation over here. Here's the ore bin. Of course, they had it set up for classification. That's why they got the ore bin with a large bin, ore bin with a small bin. It's an ore bin and a head frame together. Here's one of the plates right here. They have 2 of these plates. It's an automatic dumping skip. That's what it is. You see a lot of those, and they use them today. And it used to sit up there. I remember as a kid coming up here and playing on it. They had 2 of them. What type of ore they're getting out of here? See that? That's silver. I got sulfides here. and you could smell it. Running all through here, you can see where it's all nasty and rusty. Here's what's happening is the sulfur is oxidizing out, leaving this stained rock behind. I see a lot of oxidation. Look at that oxidation. Look at that. Oh, it's so good. Yeah. You can just taste it. Now I want you to take a look what they were following. Right there, you see that? Oh, you see the oxidized zone? It's a gossan sticking up out of there. Oh, that is so juicy. And you see all that decomposing granite, which is the basement rock around here. You can see where they dug a trench right in here, and it's got the same strike as that oxidized gossan I showed you. It's the same exact vein structure. They followed it down. Ooh, I bet you they're getting some juicy stuff out of here too. Ooh, yeah, let's go take a look at that. And then they said, to heck with trenching, we're just gonna follow it down. And you can see the shear zones right there. That would be the footwall, and that would be the hanging wall right there. You got a lot of mica schist up here, biotite mica schist. It's real shiny. People look at it and they think, ooh, I found something. You didn't find nothing. They got a lot of granodiorite up here too. You got a lot of granite up here, a lot of gneiss, and then when it melts, it becomes migmatite. Not completely melted, just enough to make it all wavy looking. You got brecciated quartz up here galore. You got a lot of fractured quartz up here. You got plain old granites up here that has tons of case bar in it. It's a mineral wonderland up here. Yeah. Ooh. Look at all these old cars that are buried out here. Look at that. They use them as a berm to help keep the water from flooding in. I've seen it done before. See that? That's decomposing bedrock. They call that saprolite. See it? What's this? Laterite. This is a laterite deposit. And these can be extremely rich. These are like the ones in Australia. And if you look over here, you can see what? This thing is just gobs and gobs of iron. See that? Look at that. Now I know why they were mining the heck out of this area, because the gold is locked up in this laterite, and you can get some really nice looking gold in this stuff. Right above me, I know it's hard to tell, but I've got cap rock up there, which is andesite. And then down below here, decomposing bedrock, which is saprolite. And then in between, I got the laterite. Remember the laterite deposition? Look at that. See that? All that black iron in there. Oh, you can find lots of wire gold in limonite, secondary enrichment, especially supergene. Why? Because the gold has actually been broken down into ionic form, put into solution, and then redeposited. Ooh, isn't that nice? You don't see those every day, do you? Oh, I tell you what, this needs to be in a museum. For you out there that know what stamp mills are, you've probably never seen one like this. Come here, look at this. Now, instead of having the traditional stamps like you're used to, it's only got one big stamp in the middle. You see that? You got the mortar down here, the big bowl, and then you've got one cam up above. So most of y'all are used to seeing banks of 5, and that's how they normally are. But this one, and of course this one's been locked up, you can see where you got your, this is the mortar, there's the bowl down there, and it just pounds the heck out of it, and then eventually it sloshes over. And then you'd have your what? Your copper sheets right here with your mercury on it, so you can collect your gold. Look in the back, son. See that automatic feeder in the back? Ore sitting in the back of this ore chute right here. You see that? And then right here you got your gear mechanism. And then down here is the feeder trough and the plate that feeds to the back that goes into the very back of the stamp mill. Now the way it works is every time this stamp goes up and down, it hits what? This little guy right here. This little fork. See that? And the fork goes up and down every time this stamp goes up and down. And as it does so, what? This whole mechanism on this T-bar is connected to this guy right here. And it advances that gear 1 notch every time that stamp goes up and down. So this goes up and down, chunk. It brings this wheel up right here because there's a lock right here. You see that? So it moves this wheel, chunk. As it does so, it turns this, chunk. As it does so, the ore's sitting inside of there, chunk. And then what happens? The ore's sitting in here, comes through this little feeder, chunk. This whole plate's rotating, remember now, because it's connected to this. And it comes out, chunk. And down inside it goes to get crushed, a chunk. Yeah, got a whole bunch of other information I gotta tell you. All right, you got two different schists up here. You've got green schist and you got amphibolite schist. Amphibolite is usually dark green or black. You take your jeweler's loupe and you inspect it. And of course it's gonna have tons of mica in there. All schist has mica in it. Right there, check it out. You can see iron staining right there in the foliations of this schist. This is some good looking schist, I tell you what. You can always tell schist, the mica particles are really, really big, real platy. And they're all sandwiched together from the heat and the pressure. Ooh, I just love finding green schist and blue schist too. Ooh, those are good indicators for gold. All right, see all that green schist in there? Okay, and see all that? See how soft that is? Look at that. You can see where this has been altered. You got hydrothermal fluids running in there in the foliations, and you can see a lot of it over there. Isn't that pretty? See all the hematite in there? Ooh, I got magnetite in there too. That's nice. And they were hoping that that would turn into some better mineralization. You know what that is? That's an old school shaker table. Tell you what, you find these here in the right area. Got some chert out here too. I didn't think I'd have chert, but I got chert out here. Because my sniffer's going off the scale. My gold sniffer. Yeah, ooh, getting all tingly. My spider senses are, they're at work. Yeah, there's gold in this area. You're gonna see a lot of that too when you're walking around the gold fields. That's what's called biotite schist or mica schist. Biotite is just a classification of mica. You got muscovite, you got biotite. Those are the most common, but there's a whole bunch of them out there. So if I got a lot of biotite in there, mica, then it's biotite schist. Green schist, obviously, it's got chloride in it, and so on and so forth. And that's how you classify your schists. I don't want to hear no funny comments on that one either. Huge crystals, there's a huge intrusion here. Ooh, that's what makes this place so good. And that's why there's a huge copper deposit across the ridge. All right, now, whenever you're in a high sulfidation zone, you start seeing these rocks that have this weird yellow tinge to them. I can tell right away without even getting involved, this is sulfur that is oxidizing out of the sulfides. See that yellow? And when you break it open, you can really smell it. Whenever you break a rock open, blow on it, get all that dust off. You see that? That's what they were finding out here. They found a lot of silver, gold, lead, zinc, and of course copper, sitting on one of the largest copper deposits in Arizona. See all the gleam in there? Isn't that pretty? And then you can see all the pyrite in there. These are all sulfides, the sulfide family, and they found lots of sulfides out here. Also, along with pyrite, they found chalcopyrite, which is what? Copper pyrite. They also found sphalerite. It's a zinc sulfide. When they first discovered this mine, a lot of the surface ores were oxidized, and they were extremely rich, down to the 150-foot level. That's because of weathering. All the sulfur's oxidized out, and that's what you want. It's like a big fat Gaussian sitting on the top, and any of the good stuff is left behind, like gold. That's what I want. So when you come out here, you bring your rock hammer and you chip this stuff open, and you're gonna see what they were looking for if you did your research. Well, they got a lot of sulfides out here that were coming down from below the 150-foot level. You see that? Isn't that pretty? There's just tons of it all over the place out here. There's another one right there. You see that? Now, like I said, I don't advocate roasting. It's very dangerous. So don't I want to see nobody out there collecting up pyrite and roasting it and find out there's arsenic in it and you choke over and I get a bad comment from your relatives. So let's go look at some more geological formations because I'm getting tasty for that shiny. Got 3 different types of deposits coming off of 2 veins that ran up through here. And one was a parallel vein only 50 feet away. Remember I told you that's why they cross-cut looking for parallels. You got disseminated, you got stockworks. You can see the evidence of that up on the hill. And then of course you got sheeted veins. This is a classic example. This is stockworks. You got a whole bunch of little tiny fractures in the rock and they've all been filled up with silicon dioxide and hopefully mineralization. They're not very big, but they can be all over the place. And that's one of the deposits up here. And if you look carefully, you can see what? Inside the quartz. That's right. See all the sulfides? All throughout there. Yeah, that's pretty, ain't it? Oh, there's some big ones right there. Look at that. Oh, there's some right there too. Look at that. So in this particular deposit, they had stockworks running down there, and they also had lenticular bodies down there. Now you can see that this is disseminated. See that? Disseminated means it's just all throughout. You can see all the sulfides in there. On the other end of the spectrum, you got this really dark rock. And some people would say, oh, that looks like gabbro. No, it's not gabbro. This is more of a metamorphic rock. This is hornblende metadiorite. It's really heavy, it's really hard, and then you can see that it's disseminated, but also along these joints. Like there's one right there. See that joint? Running right along there? And you see how much mineralization's in there? That's a good example right there too. The lithology of this area is obviously, you can tell, a lot of gneiss and granitic rock. It's from the late Cretaceous period. And there's a lot of folding and faulting going on here. A lot of the silver was locked up in sericite and argentite. And they found a lot of it, a lot more than they did of gold. And they were finding 200 ounces per ton of silver. Don't get excited. And only about 1 ounce to the ton of gold. I'm not that excited anymore. But I wanted you to see some of these rocks. And if you come up here, you're gonna see tons of them everywhere. Don't get excited. And if you got your jeweler's loop on like you're supposed to, get in there and take a look at some of these sulfides. You're gonna see this really orange coppery look, chalcopyrite, and this nice yellow, which is standard pyrite. And then some of them, you're gonna break open, you're gonna find galena, which is a sulfide of lead. Why are we stopping here? I wanna show you this little guy right here. What is it? Quartz monzonite. You're gonna see a lot of that in your USGS reports too. Basically an intermediate in between diorite and granite. It's in the family of granite, and even though it's got word quartz in it, there's not a lot of quartz in there. There's tons of mica, and then there's a lot of feldspar. The most popular and common one is your K-spar, potassium feldspar, or K-spar for short. You're gonna hear that a lot. And the other one is what? Plagioclase feldspar, and it's mostly white. And of course your K-spars, it's gonna have like a pinkish color to it, but it does come in white and red and a whole host of other colors. Sun's dropping. Hold on, let me do my finger trick. You can see where somebody's been digging under these rocks. Now, speaking of that, I want to talk to you real quick. All right, so if you're in a creek like this, and it's in a gold-producing district, that's very important, and you got a big marker like this sitting on the bedrock, if you can move this rock, or what I like to do is I'll drill a couple holes about 3/4 of the way down, load it and blow it. That way it gets it out of my way. But my point is what? That all your heavy minerals, magnetite, gold, things like that, they're gonna be trapped underneath this marker when it's sitting on bedrock. If it's sitting on top of gravel and sand, they just blow right up underneath there. Now we're in a gold producing district. That's rule number 1. And we're out here in one of these old washes that cuts through all this alluvial material, where it looks like an old timer come in here and he started punching into this stuff because he was looking for the Motherlode, I tell you. Well, why is this important? Well, it's simple, really, because if this has got somebody's interest, that means that they were finding something because they wouldn't dig a hole. At least maybe they found enough that would keep your interest. So what I would recommend and what I'm going to do is I'm going to come in here and I'm going to sample. And that's what you should do too. I'm bringing a 5-gallon bucket. I'm going to collect material from different zones. Then I'm going to go ahead and pan it out. If there's any gold in that sample whatsoever, I'm going to come back and I'm going to be a little bit more methodical about where I sample. So I need to localize what's called the pay streak. Sometimes there's multiple pay streaks, not just one, but sometimes different time zones of deposition. You have to know this. So what I would do is I'd get in there to try to localize it, and I'd also expand on it to see if there's more pay streaks in there. So what I want you to do is when you come out here to areas that are known to have gold in these old alluvial gravels, and you find one of these diggings like this, I want you to go in there and sample it. Do a bulk sample. A 5-gallon bucket should be plenty. You're going to get it all from the edges here, down around the bottom. You're going to get the slough out and get to the bottom of that. Put that into a 5-gallon bucket, take it, classify it through a 1/4-inch screen, pan it out with some jet dry. Take a look at it with a jeweler's loupe and see what you got. Now, if there's gold here, that means it had to come from where? From a source, that's right. And what you can do is try to localize that source by going up into any of the surrounding hills or mountains. Now keep in mind that you have erosion, and erosion's gonna wear down those mountains into small hills. So don't think the source might still be there. It might have disappeared 100,000 years ago, maybe even 1,000,000 years ago. It's hard to tell based on the deposition unless you know for a fact if it was Precambrian or what have you. So what I want you to do is become familiarized with the types of rocks that are in gold producing districts. Now in this particular district, I've got a lot of Precambrian schist. Now schist is nothing more than shale that has been squeezed and heated. Shale comes from mudstone. It's a clastic rock, and as it's pressed and squeezed under low heat, you'll start to see mica form in these sheets and bands. And sometimes you'll get pyrite crystals growing in between these sheets as well. A little bit more heat, a little bit more pressure, and it's changed into what? Slate, which is a metamorphic. So it has gone from sedimentary to metamorphic. More heat, more pressure, it becomes a piece of schist. Now schist is easy to identify because it's foliated and it usually breaks apart real easy, and you can see where a lot of the mica is starting to form in the foliation. Now a lot of times you can also have gold that will form or pyrite that will form in the foliation. Now why is this important? Because a lot of times in your USGS reports they're going to say there's Precambrian schist, and right next to it you have quartz. This is nice blue quartz, and you can see where the schist was up against here and then broke away, and you can see oxidation going on in there, probably from magnetite, and probably I've got also limonite in there, and that's what happens when a lot of your pyrite oxidizes, is you get limonite. Now that's great news because you want the sulfur to go away. You don't want to have to roast it. You want Mother Nature to roast it. So when you see that red, it could be limonite, which is good because the gold will be left behind, or it could be oxidized hematite or magnetite. I would be checking along here with a jeweler's loop or maybe a Falcon MD20 or something like that. There are other pieces of quartz out there. This is called bull quartz, and they call it bull quartz because it's barren, there's nothing in it. But it is a good indicator if you see an outcropping of this, especially in this area. Along the joints, sometimes you can have mineralization in there. You see that? Where it's oxidized out. This is a good place to be running your metal detector over to see if there's any small traces of gold, or you can crush it up in a mortar and pestle, or if you got a small handy portable rock crusher, you can grind it up right away, put some jet dry in there to break the surface tension, pan it out. Remember, you got the three types of rocks: sedimentary, metamorphic, and igneous. A lot of your gold is going to be found in what? Metamorphic rock, a lot of it. And of course, most of your basement rock, your continental crust rock, is going to be igneous. You have all different variations. I could go on and on about this, and then you've got all different models of deposition, but at least know your basics when you go out to a gold producing district and know what the rocks look like that are hosting the gold. Woo, I tell you what, who needs a gym? Just be a gold miner. All right, I got my 2 buckets here, and yeah, you're gonna get wet. When you're panning, you want to do big swirls like that. You see that? And what's gonna happen is all the big rocks are gonna come to the top just like that. See that? All these big rocks came up to the top. And what I'm doing is I'm stratifying. You see that? Don't worry, if there's gold in there, it's staying in the bottom. See that? Then I can rake them to the back if I want. That's why you gotta classify to get those rocks out of there. Then you're gonna tilt to the front, shake, and then let the water wash it right out. Again, round and round and round. Back and forth, gently pan that out just like that. See that? Not getting all crazy with it. And I got a rock there that don't want to go nowhere, so I'm going to hold on to him. All right, now let's see if we got anything. Come here, because that's a lot of work. I better got something from that. Let's see what we got. Got a whole bunch of magnetite. See that quartz in there? Ooh, I see a speck. I see a speck. I see 2 specks. Come on, baby. Daddy needs a new pair of shoes. Ooh, wow, look at that one. Isn't that a funky looking piece? And I got a big old chunker right there. I got a whole bunch of little fines in there. I don't know if you can see that when my fingers point. Oh, they're all in there. And I got some fines down there too. Man, that's a neat little piece. Look at that. Looks like the letter Y or a witching stick. Do the Alabama bump to the, oh, there's a piece of lead right there. You see it? Isn't that sweet? Ooh, yeah!